In this video, I will talk about independence. Independent events or independent random variables. Now, I'm sure you know from probability 1. Okay, let me start by talking about independent events first. Okay, you know from probability 1, if you're given two events, say A and B, they are said to be, these two events are independent if the following is true, that the probability of A intersection B is equal to the probability of A times the probability of B. Right? That if you have two events. Now suppose you have n events, say A1, A2 up to AN. And these events are independent if the following is true. The probability of the intersection of the n events is equal to the product of the probabilities. Okay. That's okay. These two are to do with independence of events. Now let's suppose how we can define independence of random variables. Right, now suppose you have, say, two random variables, say x1 and x2. And these two are independent if the following is true, that the probability of x1 less than equal to little x1, x2 less than equal to little x2 is equal to the probability that x1, this probability multiplied by this probability, right? So if this holds for all x1 and x2, right? Right. So if this condition is true for all x1 and x2, then the two variables x1 and x2 are independent. Right? And similarly, if you have more than two variables, suppose you have x1 to xn, Okay, they are independent if the following is true: the probability the joint probability, that is of x1 to xn, is equal to the product of the individual probabilities for all x1 up to xn. Okay, so this is the definition for these variables to be independent of each other. Okay. Right. The next thing I need to talk about is the following: is a related issue, which is what is known as a random sample. A random sample, so you say that suppose you have x1 to xn, right? These are random variables. Is said to be a random sample, right? Is said to be a random sample if the they are independent random variables and follow the same distribution. When I say that they follow the same distribution, I mean the following, that is, their CDFs. Remember, CDF is the cumulative distribution function. So random sample is an important concept, at least in this course. So you need to be clear about what a random sample is. So it's a sequence of independent random variables with all the variables having the same distribution function. In other words, the same cumulative distribution function. Right? Now, before I go to the next video, I would like to do a couple of examples. So let me start with example 1. right? So we have a random sample from a Poisson distribution with parameter lambda, and the question is to find the probability, the joint probability that capital X1 equal to little x1, capital Xn equal to little xn. Right? So to do this, I'm going to use the definition of, the condition I gave you earlier for variables to be independent. Remember that something is a random sample means that these variables are independent of each other. So we can write the joint probability, right, as using independence, using the fact that these variables are independent. You can write this as this. Okay. Now each of these probabilities, we are told that each of these has a Poisson distribution. So this guy here is, I'm sure all of you know the PMF of the Poisson, which is E of minus lambda, lambda power x1. Okay. And this guy here now this we can simplify this. There are n of these terms, right? So combining them, you get E of minus n lambda, and you have lambda power x1 up to lambda power xn. So that would be lambda power right, and then in the denominator you have x1 factorial up to xn factorial, right? So this is you can even write this further. You can write this, simplify this further, and in place of this, you can just have the sum. Okay, and in place of this, you can have the product. Okay. All right. So this is the answer to example 1. All right. The next example. So this is for a discrete case. Now I'm going to consider a continuous case in example 2. Right, so here we are supposing that we have a random sample from an exponential distribution with parameter lambda, and we want to find the following. Okay. Right. So I'm going to start with the first thing I'm going to do is I'm going to use the fact that these variables are independent of each other. And using that fact, you can write this as as the following. Right. Now this is the CDF of x1 at little x1, and this is the CDF of xn at little xn. Right. Now I don't know whether you know that for the exponential distribution there is a closed form formula for the CDF, which is given by this. So this is the CDF of the exponential distribution at x1, and this is the CDF of xn at little xn, right? Okay, so this is let me write it down here, using CDF of the exponential distribution with parameter lambda. Right, so this you can rewrite as the product I from 1 to n So this completes example 2 and also completes the video on independence events and random variables. Okay. In the next video I shall talk about sample mean and sample variance.